Hi everyone, welcome back to my channel. So today we will be discussing about mole fraction. Mole fraction is another method of expressing concentration of solution. So it is the ratio of the number of moles of one component to the total number of moles in a solution. So it is represented by a capital letter X. So the necessary formulas we will be using to solve for problems involving mole fraction are the following. So in my screen, you can see the mole fraction X solute A. To shorten this, we use the representation X sub A since mole fraction is written as X and solute A. So mole fraction of solute is equal to the number of moles solute divided by the mole solution, number of mole solution. So the second one is the mole fraction of solvent. Let's say the solvent will be B equal to the moles solvent divided by the number of moles solution. So this one is represented by X sub B. So the total for the mole fraction of solute and the mole fraction of solvent should be equal to 1. So for solving for the denominator or the number of moles of solution, we have the number of moles solute plus the number of moles solvent. So we use this mole fraction of solute plus mole fraction of solvent in checking. It is used to check if your values for the mole fraction of solute and mole fraction of solvent are correct and should be equal to 1. So we have the problem. Let's say a solution is made by dissolving 1.25 grams of sodium sulfate in 65 grams of water. So calculate the mole fraction of the solute and the solvent. So we have, it is divided in 4 steps. So I'm just going to write this. Step 1, we will solve for the number of moles of solute. So solving for number of moles of the solute. So our solute is the sodium sulfate, the Na2SO4. So we have the number of moles of sulfate, N of Na2SO4 is equal to the mass of the solute, Na2SO4, divided by the molar mass of the solute so we have the mass of the solute as 1 grams and we do not know the molar mass of the solute of Na2SO4. So the molar mass can be found in the internet of all the compounds or molecules. You just search for, in your Google, you just search for molar mass of Na2SO4 and the result would be 142 gram per mole. So the unit for molar masses of any solute is usually gram per mole. So we have this. You use your calculator to solve. We have cancel the gram out. We have 0.088 0.088 mole. So step 2 would be to solve for the number of moles of solvent. So the solvent is our water, H2O. So we have N number of moles N of H2O. We have the mass of H2O divided by the molar mass of water, of the solvent, mass of H2O. So we have the given 65 grams divided by the molar mass of H2O, which is, if you search it on the internet, it is 18.015 gram per mole. So using your calculator, this would be equal to 3.61 mole. So the next step would be step 3. We have step 3 is to get the total number of moles. So this is simple. You can just total number of moles represented by N subtotal equal to N of solute plus N of solvent, which we solved previously in step 1 and 2. We have 0.0088 plus 3.61. So we have 3.62 moles. So the next step would be step 4. Which is to get the mole fraction of the solute and the solvent. So we will be using the mole fraction formulas we had earlier. So for the mole fraction of X sub A, have X sub A, we have the number of moles of solute divided by the number of moles of solution. We have N of solute N of N of solution. It is the N total is the N of, this can be written as the N of total number of moles in a solution, since the solution is equal to solute plus solvent. So we have 0.0088 divided by 3.62. This is in moles. This is also in moles. And you cancel this out. The mole fraction is 0.0024. For the mole fraction of the solvent, we have X sub B. We have I'm just going to write this for formality. Solvent 3.61 moles divided by 3.62 moles. So we have 0.997. So as I've said before, the total for x sub a and x sub b should be equal to 1. So to check, use your calculator if these are indeed equal to 1. So it is 0.0024 plus 997. This is equal to 0.999, which is eventually be equal to. So the mole fraction for the solute is 0.0024 and the mole fraction of our solvent 0.997. And we add together, we get the correct value. We have
997. And we add this together, we get the correct value. We have the solvent and the solute and the solvent equal to 1.